Welcome to session 4 for the series 1. We have been talking about this series about software tester profession. Main thing which we wanted to point out that this profession anybody can get into regardless of their background or their qualification. As long as you understand the basic principles, you should be able to write the exam, ISTQB exam, which I keep on referring to again and again. With that kind of basic certificate with you, you should be able to get into some profession and entry-level job for this. I can just push you and you can keep on asking me questions and I'll try my best to answer those. Okay, I won't go through all these slides because we have already gone through previously as well. My profile. The only thing which I want to highlight here is best way to reach me is WhatsApp number, which you already have with you. And you can share your thoughts with me. And this is Sonia Sharma, my co-facilitator. She's also part of this initiative, and we do this. We run this combined. Now, coming to this point here, till now we have learned about all these points which are black in black font, and today we are going to talk about test case management and defect management. So today is session 4, Friday, 18 December. This doesn't mean that this series is getting over and all those things. I will start new series with different topics depending on how the audience reacts back. So coming to the recap of the first session where we talked about what exactly is the purpose of software testing. As you see, the intention is to make sure that all the requirements of the software, those have been fulfilled. And if those are not fulfilled, then we need to, that's where the software tester comes into picture. And their job is to find the defects and log those things. Software programmers, those guys, they are going to fix those defects and make sure that the users, the end users, they get enough confidence in the level of quality of that particular software. Moving further, in the session 2, in the recap, what we did in that one, we tried to distinguish between various terms like testing, debugging, quality control. Oh, I didn't change this one. The last one should be quality assurance. Anyways, coming back to the testing, that's the job of the software tester. Debugging is done by the programmers. Then quality management has got these two domains known as quality assurance and quality control. And testing is directly related to the quality control. Coming to this one, this is a software development lifecycle. In case you're not aware of this cycle, what happens here in the beginning, the software requirements are gathered. Those are prioritized, those are analyzed, and there's a particular document that is known as business requirements document. All those things are documented in that. Based on that, the business analyst does the design part here. So all the high-level design, whether it's in terms of the screens or functional specifications or any kind of details about the background calculations, all those things happen here in the design part. Once those design documents are ready, those are passed on to the development team, that is software development team. Software programmers, they are going to program that particular design in a particular language, and that's what the coding is done in this particular phase. In the next one, the fourth phase, we are talking about the testing. This is where software testers come into picture prominently. Although testing happens in other previous phases also, but our job, which we are focused on, they do main testing here in the fourth phase here. And then finally, when everything is taken care of, we make sure that the product is of good quality, of acceptable quality. Then the product gets into maintenance phase. Then we talked about V model of testing. Anybody who wants to speak about this thing instead of me talking about this? Ashmit or Sandeep, do you want to tell about this? What is your understanding of V model of testing? You need to unmute. Okay, I'll help you in here. So in the V model of testing, what happens? We are talking about the requirements in the beginning. Then we talked about the design, high-level design. That is done by the business analyst. Low-level design is coming to the role of system analyst. And the software programmers, they do the coding. Now, this is the part where the unit testing or integration testing or system testing takes place. This is the part, system testing, where mainly the software testers come into picture. And we'll get into more details about this part. Also touching on these types of software testing, we talked about what exactly is the classification of the software testing types. First one, we have got the static testing, then we got dynamic testing. Actual work of the software tester, it belongs here. Under the dynamic testing, you got the functional testing, and you got the black box testing. Black box, remember what I told last time. It's as if you don't know how the programming is done inside the software. You just care about the requirements, business requirements. And as long as those business requirements are met, those are fulfilled, that's it. That's what we are looking at. And if those are not fulfilled, then the software tester is supposed to raise some defect. And we are going to talk about those test cases and defects in this discussion today in more detail. I'm just making a background of all this session by going through the previous sessions, recap of those. And here, what we talked about, the difference of functional testing and non-functional testing. Functional testing is mainly focused on the requirements. Non-functional is focused on the customer's expectations. I won't get into details because this is not our focus today. I just wanted to highlight these things in today's session. Black box and white box testing. So black box means we don't know what is sitting in there. As long as we give some input and we get the desired output, it's all good. So that is the purpose of black box testing. So imagine this thing with a car where we use a key, car key, and then we don't know how the internal structure is there of the car, as long as by inserting the key there, the car gets driven, gets started actually. So that is how the user does not care about how the things are inbuilt in there. However, on the other hand, which one you call? Car engineer? No, automotive engineer? That person may be knowing more details about how the internals work for the car. And that person knows, okay, keys are inserted and inside whatever happens, and we get the desired output that car gets started. Similar to that analogy, we have got for the software that we put some input as long as all that code gets executed properly, and we should get the desired output. That's the purpose of black box testing. And our job as a software testing is focused on black box testing all the time. So remember, the black box is for the software testers and white box is for the programmers. Now coming to the actual point of discussion here in today's discussion, we are going to talk about test case management and defect management. So let's understand what is a test case. Test case means we are writing some step-by-step instructions. What is the purpose? What do we achieve by doing this? Basically, we want to verify that software is behaving as it is required to behave, right? So you want to make sure, first of all, test case, in other words, I will say, we are documenting a test case. We are writing down all the different steps, how we should be doing something, what exactly we should be doing, why we are writing all that, so that we want to verify that software is working as expected. That is the whole purpose of a test case. And what's a defect? Defect means, okay, I won't read these complicated definitions, but you know the idea here. Defect means something is wrong with the software. And this must be recorded. When the software tester sees that there is something wrong, they record it. or in a document, MS Word document or Excel sheet or whichever the defect management tool they have, then that defect gets assigned to the software programmer. Software programmer is going to resolve that defect, fix the code, and send back for testing. Now, there could be two situations here. When at this stage, at the last stage, when the code has gone to the tester again, they may see that it is not fixed yet. So basically, they are going to return that defect back to the software programmer. If it is fixed, then they're going to say this defect has been fixed, it is closed, so we are good to go to the next level. Any question up to this point before I move further? Are we good? You can use your participant that's, see that you should be getting yes or no, that kind of button there. Okay. Coming back to this one, we already talked about what is a test case and what's a defect. Okay, good. Thank you. We are moving to the further slide. I'm going to give you some examples here about the test cases. Now see, the test case could be positive as well as negative. When we say positive, that means the regular normal flow, and other one could be negative, where we just want to make sure that the other kind of case is also possible. So we are having this functional test cases example here. And what these test cases are all about, it's a very simple example where we are going to talk about the login page. See, any login page, it could be of your even laptop, it could be your Facebook page, it could be your Gmail, or any normal application as well, because most of these examples are very generic examples, which I have shared with you. So first one here, see the serial number, 1, 2, 3. Functional test cases, that means all are black box test cases to be run by the software testers. And this is the type, negative or positive, that kind of test case. So first of all, we are going to see, verify if a user will be able to log in with a valid username and valid password. I think it's very sensible kind of statement here. We want to make sure that if the user enters a valid username and a valid password, they should be able to log in, right? So that is a positive test case. Now, on the other hand, if user enters invalid, let's say invalid password or valid username or other way around, then it should not be, the user should not be able to log in that application. So basically that's called as a negative test case because we are verifying that it's the other way around situation. Now the next one could be verify the login page for both when the field is blank and submit button is clicked. In this one, if you understand this properly, on the login page, they are telling that just leave those fields blank and tell submit or login. That means what happens? The user should not be able to log in. That's again negative test case. Most of the time we see the forgot password functionality. As you know already, if we forget the username or password, click this one. It's going to ask our username and then ask some questions also for the security purpose. Once you answer those correctly, that's where you get the new, you get a link to reset your password to your email or phone, whichever you have selected. So all these points are all about, verify the forgot password functionality. So I won't go into all these 7 test cases. The whole idea here is that this is how the test cases are written in the document. They are identified as whether it's a positive one or negative one and simple statements. In reality, those are not very simple statements as they look like because I'm going to get into more detail of this one. And I'll request whoever's mic is on, please mute yourself. Thank you. Okay, so this is how a test case looks like. Earlier, we saw these simple statements here, right? Verify if a user will be able to log in with a valid username and valid password. Now we are going to expand this statement in a proper test case. this is how it may look like. Why I said may? Because every organization or company, they have got their own way of doing things. This is very generic template of test case here. So first of all, even if you ignore the top parts because those are more specific here, ID means identification. We are just going to write some identification, some number there. Then priority of that, high. I will not get into this detail because that's not very relevant here in this discussion. I would like to more focus on the bottom part here. So remember, we talked about what is a test case. That's a step-by-step instruction. So these are the steps here where you see the action, launch application, enter correct email and password and hit login button. So in another way, you're just telling the user how you are going to execute this test case. And what are the inputs? The user is expected to be there on this particular page, and email ID is already existing, password is also already existing, and that's how we are going to input that information. What is expected? When you launch application, Facebook home should be displayed, and when the user enters the user ID and password, then login becomes successful. And same thing, okay, not same thing. Expected output and actual output. These are different things, as you can see from the name. Expected is what we are expecting here. Actual may differ from the expected output. For example, in this particular case, although it's saying login success, but maybe because of any software defect, it's not successful. So by that I mean expected output and actual output differed. That means there's a defect, and software tester is supposed to log in that. Test browser, you give that specification, Internet Explorer version 11. Both cases are passed, that's why it's passed. Otherwise, user should have written fail there. And who is writing the test comment? This user named Priya on this particular date, this time, and saying, everything, all these steps are successful. So this is an example of how the test case looks like with all the details here. Like I said, depending on the organization where you may work, the format may differ, but overall, these kind of details are mostly there. Coming to the quality assurance management, we have got these three things there: requirements management, test case management, and defect tracking. Requirements management is done by the business analyst. They take care of that. Test case management, defect tracking, mainly the test lead, test manager, they take care of these parts. And the people in the testing team, they work in this part as well, and they work towards defect tracking as well. Okay. Before I go to the next one, any question up to this point? What is a test case, or what information should be there? Any question about this, so we can tackle those? Assuming no question right now. So I'll move to the next part here. That's about the defect. Now, in the software terminology, see all these different terms here: error, mistake, defect, bug, fault, failure. In a common English language, we might think all these terms mean the same, but in the software testing profession, these have different meanings here. So let's say we are talking about the error or mistake. The understanding here is the software developer or programmer, they found it, and whatever they found, that is termed as error or mistake here. All these terms are used by the testers when they find something that may be known as a defect or bug or fault, depending on various criteria. And if a customer finds out something, anything which is not working, they log it as a failure. So this is a quick distinction between all the different terms which the professionals use. Okay, here is the defect life cycle. What happens here? Okay. Someone wants to take a stab on this and explain to other people. Vakla, would you like to say?
No, you carry on, Arvind.
Okay, sure.
Sorry.
No problem. So in this one, in the defect lifecycle, what happens here? Let's say someone has found a defect, and what they do, they assign that not assign, they document that defect, and that's the status of that is new. It's a new defect. Then comes that defect comes to the next level where someone is looking at that, and that defect gets assigned to some member, maybe some software developer or development lead, whoever. If it is assigned to the development lead, they take care of that defect as a single contact person, and that person assigns a defect to a software developer. And they see if this is an issue, then okay, yeah, then that means the cycle goes longer. And if this is not an issue, if it is not a defect or whatever it is, then they say, okay, we are rejecting this, and that defect is done, taken care of. It might be other situation where the software tester is going to tell them that, no, you cannot reject it. It is a defect, and you should be looking at this. And then the defect comes back to the cycle again. And if it is an issue, then what happens? Software programmer is going to fix that defect. That is going to be verified by the software tester. Software tester is going to see if this issue is fixed or not. If it is fixed, then they're happy about it, and they say, yes, we have verified it, and we are closing this defect. And if it is not fixed, then they go to this part. This path is all about that they are reopening the defect, and the cycle comes back to the original one where we started. So this is how the defect lifecycle looks like in a real-time situation. Actually, I will say similar cycles are applicable for other terms also, which we had here, but the handling of those issues could be different. Now, this is how the defect looks like. I just took an example from net where we are talking about the details here. What exactly is this? Okay, this is a bug. What's the priority? There could be different priority, let's say like low, medium, high. What versions? Even if we ignore all these points here, what I want to highlight here is the description where the software tester is going to give information about that defect. First of all, what exactly is this about? The description kind of thing on the top, where you see any participant of a group conversation should be able to rename it. So first two lines are there for that. Now steps to reproduce is very important, because here, why we want to write all the steps? The reason is if you write all the steps in detail, then the developer, I mean the software programmer, they're going to follow the exactly same steps, and they will verify, yes, that defect is existing there and they are supposed to fix it. If the software tester is not writing the defect description, I mean steps to reproduce in a proper way, software programmer may say, you know what, this is not a defect at all. Don't even send this to me. So it's all waste of time and energy there. So it's as an effective software tester, it's your responsibility to write the steps in a very clear manner, just the way it is. Like, open the site, sign in, open, all the different steps, so that the software programmer or whoever is going to look at this defect, they should be able to reproduce it. Ultimate objective is the software programmer is going to fix it. That's why we are doing it. And there could be some screenshots also just to assist the software programmer that, okay, these are the screenshots of that error, so that they know what exactly kind of error message they're getting, and they will be taking care of that. Yeah. So in this one, although we have covered the test case, template and the defect template also. In real world, what happens, all these things, every company has their got own processes. They use their own tools also. For test case management, let's say, what information we are going to write, something like this. People might be using simple MS Word application, Word documents to document the test cases. There could be some organizations I have worked with, they used Excel, and some are using even different test management tools, like, quality center, those kind of tools. The whole purpose is to make sure that the full repository of the test cases is available to the users. So anyways, regardless of what is the tool used, uh, information is very similar. It may not be exactly the same, what we see here, but as long as you understand the importance of these fields, you should be able to understand what the tool is doing. Similarly, for the defect, just like I have given this defect lifecycle, there could be some defect management tool. All this information, what we see here, it could be part of some tool. When I say the tool, by tool, I mean software. There are so many softwares available where you can record these different things, whether we are talking about the test case or requirements or design or the code or the defects. All those things can be stored in a repository. Now, depending on the size of organization, they may say, yeah, you know what, just write all these defects in an Excel sheet. So that's the way you're going to work. But still, the important thing is, even if you're working in that Excel sheet instead of a software tool, the job as a software tester is to make sure that all this information, which is highlighted here, especially the description and the steps to reproduce, those are properly highlighted. Not only that, there could be other important information relevant to that company, if not all of these points or all of these fields. But still, whatever is relevant to them, that information should be recorded here. I don't think I wanted to add anything to this point. And lastly, by mistake, my screen has gone unshared. And I'm going to share it again. Okay. So overall, you remember why we started this testing series for the training. The whole objective is you should be getting enough push that you write this ISTQB exam. This exam has got 40 questions and you got 60 to 75 minutes. 60 minutes if English is your language. If you are not speaking English, then they may give you additional minutes. But assume that you are going to get 60 minutes for the exam, and the passing mark 26 should be correct out of 40 questions. And that's it. Any question which we want to talk about, or I will discuss my further plan after taking care of your questions.